Hello, my name is Agil Kochambaraman Ali. This is my demonstration video for machine learning assignment, and I used two models SEM and KNN for image classification dataset fashion mini stancy pattern, and I applied skitline libraries and hyperparameter tuning, classification report, F1 score, accuracy and all things. And firstly, I upload or imported the main libraries like SVC for SEM and KN classifier for KNN and model selection, test splits, classification report, confusion metrics, and matplotlib and Seaborn for visualization and gridsearch CV for hyperparameter tuning. Firstly, I loaded the and also one thing I missed that the fetch OpenML. I used this fetch OpenML for importing the dataset, and then I loaded the fashion means dataset using the OpenML, and I split the data into three: train, test, and validation. And the fashion minutes is a grayscale image of 70,000 images of clothes, mainly for clothes. And I imported the fashion minutes dataset in SGM without tuning, and I got accuracy of 88%, and I used it the same in KNN, and I got 85%. And after that I used hyperparameter tuning for ACM, and I got 90% of accuracy, slight increase in accuracy. And I used the hyperparameter tuning for KNN, and there is no change in accuracy but changes in the F1 score, precision recalls and something. And this is a comparison of F1 score of both models ACM and KNN for better information. From this graph we can identify that the ACM outperform the KNN in fashion means dataset, and in slight changes. And this is a confusion matrix of SEM after tuning, and this is a heat map with confusion matrix. And from the row is mentioned as the actual classes, and the column is predictor. And from here we can found that the class 5 predictor the actual classes correctly, and the others are correctly mainly correctly, and there is something is predicted wrongly, that is the class 6. And this is a confusion matrix of KNN. KNN also predicted mostly by the class 9 correctly, like 1383 times. And this is the sample prediction of both models of a 20 classes samples. From the highlighted version is wrong prediction. From here also the SVM predicted correctly more than KNN. And this is a Sifaten dataset code. And here also I used imported the dataset using OpenML. And this is a normalization and the label to integers. And I used the sample split for like train and split with the Sifaten dataset. And I used the subset because the Sifaten is a 60,000 image with a color image by 32 by 32 feature extraction. So it takes so time for hyperparameter tuning and extraction and training. So I used the subset of 20,000 data. And also I used SEM without hyperparameter tuning of this dataset. I got 41% of accuracy. And I used KNN without hyperparameter tuning of Sifaten. I got 27% of accuracy. And after I used hyperparameter tuning by Gridsearch CV for SEM, I got 44% of accuracy. And in KNN 28%. From this accuracy we can found that SEM outperform KNN in Sifaten also as compared to fashion minutes. And both the models, thus SVM is better in this image classification of these two datasets. And this is a bar chart over here also, the SVM is better in F1 score also. And this is a confusion matrix. In confusion matrix, this confusion matrix, the SVM predicted the ship correctly, and the SVM false predicted the ship, so aeroplane like ship, a ship like aeroplane. And there are so many errors in this confusion matrix by prediction. And correct prediction is ship that 62 times. And in KNN is very scary that the prediction ship is correctly predicted, but other things are predicted differently. And this is a sample prediction of 20 classes of SVM prediction in KNN. And here the highlighted version is mentioned as the false prediction. From here also The SEM predicted better than KNN. From these two models, the fashion from these two data set, Fashion and Sifa 10, the SEM performed well than KNN. Thank you.